Okay, AP Chemistry students of 2020, welcome back. We're going to go over how to solve gram to mole and mole to gram of similar substances, how to do those conversions. Now, the case is with any problem solving, you always want to start off by reading the question, and you need to determine what is the question asking you for? What does it want you to convert to, or what does it want the final answer to be? And then you need to go back through and look at, well, what did they give me to start off with? What am I going to be beginning with to convert in the first place? So let me go ahead and read the question out to you. A chemist needs 0.336 moles of sulfur hexafluoride, SF6. How many grams will she need to weigh out? Let's look back at this question here. What is the question asking me to find? What do I need to end with? My final answer. It's always a good idea to look for the question portion of the question, or the words that indicate a question is being asked. That's like how many or what is needed, and things along those lines. So I'm looking back at this question right here, and I'm seeing how many grams will she need to weigh out. That how many grams right there tells me that my final answer needs to be in grams. I am converting into grams. The second thing I'm going to look for is, well, what was given to me? If I look back at the first part of the question, it says a chemist needs 0.336 moles of hexafluoride. So that's what it gave me. I'm going to start off with these 0.336 moles, and I need to convert them into grams. I need to figure out how many grams that is, okay? So second thing we want to do is we want to develop a little bit of a plan or a mini-map of how we're going to convert this. According to the question, we are starting off with moles of SF6, and we need to get to the grams of SF6. That's the plan now, okay? So we will start off with 0.336 moles of SF6. Now we're doing a conversion here, which means we have to multiply it by a fraction. Hope this is starting to sound familiar from regular chemistry. When we do conversions, ladies and gents, we always multiply by a fraction because the fraction indicates the conversion factor. It is the link between the two things that we are trying to convert, okay? Now let's ask ourselves, what is the conversion factor between grams and moles? What is the thing that they have in common? In this case, ladies and gents, it is the molar mass. What you should have read about on the previous slide is the molar mass. Because according to the definition of molar mass, 1 mole of SF6 will have a certain weight in grams. Well, we have to calculate that, okay? And we're going to calculate that by looking back at our periodic tables and getting the masses of each one of these elements in the formula. Let's start off with sulfur, calculating the molar mass of SF6. First, take a look at the formula. How many sulfurs are in the formula? There is 1, so we're going to do 1. We need to multiply that by the weight of sulfur. And sulfur, if you look at your periodic table, weighs 32.1 grams per mole. If you do 1 times 32.1, well, that's 32.1 grams per mole. Sorry, I'm running out of space right there. Let's do fluorine next, okay? Well, in the formula, how many fluorines are there? There are 6, so we will do 6 times, and then the weight of fluorine, which is 18.9 if you look at your periodic table, grams per mole. You're going to need a calculator for this, so go ahead and take out your calculators and then calculate 6 times 18.9. That's going to give us 113.4. Oops, let me fix that. Grams per mole. Now to get the total molar mass of the substance, you got to add those two numbers together. 113.4 plus 32.1. Okay, it's 145.5. That is the weight or the molar mass of sulfur hexafluoride. Now that we know what the conversion factor is, 1 mole is equal to 45.5 grams, we can now do the conversion, okay? All right, let's go back here to our fraction. we have 0.336 moles of sulfur hexafluoride. I need to cross-cancel this mole of SF6, so I have to have a mole of SF6 down here. If you recall, if you were in my regular chemistry class, I said that your units always have to match diagonally. They always have to match diagonally when you're doing a conversion. And then what's going to be up top is what the question was asking. It was that right there. So we're going to need to have grams of SF6 up here. Now, I taught my students, gram with a mole always gets the number 1 because the definition of molar mass is 1 mole of SF6 for ever how much the weight is. Okay? So the grams are going to be 145.5, what we calculated. And I'm going to put the equal sign down here so that we have a little bit of room. Actually, I'm going to do it a little further away than that. Do the equal sign right here. Okay. Guess what happens to the moles of SF6? They cross-cancel. And then across top, you're going to have the 0.336 times the 45.45. Then divided by 1, but we don't have to show that. So what is 145.5? You're doing this in your calculator times 0.336. I got 48.9 grams of SF6. So that means this chemist has to go into the lab, pull out 48.9 grams of sulfur hexafluoride, and then she will have 0.336 moles. Okay. All right, that's a mole to gram conversion. Let's do another example in which we're going from grams to moles. The idea is still the same. We're still going to use the same strategy. Read the question, determine what it's asking for, what are your givens, make a little mini-map of what you're converting to, and then determine the conversion factor needed. For gram to mole conversions, it's the molar mass. All right, so let's read the question. An 8.6 gram sample of argon will have how many moles? Okay. Well, what's the question asking for? Here's the question word right here, how many moles? So we're looking for moles. We need to end with the mole. What did it give us as a given? That's usually got a number with it. It says an 8.6 gram sample of argon, so that's my given right there. According to this thing, we're starting with grams of argon, and then we need to get to moles of argon. So we're starting with the 8.6 grams of argon times a conversion factor or a fraction because we're converting something, and we need to figure out, well, what is that conversion factor? Ladies and gents, when you're converting grams to moles, what is the conversion factor always? It is the molar mass. We learned that last year. 1 mole of argon is equal to how many grams of argon? Well, this is kind of nice. Argon is just an element. Look at the periodic table. Figure out what the molar mass of argon is. It's 39.9 according to the periodic table. So we don't actually have to do much calculation there for this molar mass. That is really, really convenient. 39.9. All right, now let's go back here and do our final solving. If I've got grams of argon right there, what needs to be at the bottom down here in order to cross cancel? Do you know? I hope I heard you say grams of argon, because that's exactly what you need right there. They have to be the same diagonally, otherwise they cannot cross cancel. Then up top is going to be wherever our map ended. That's going to be the moles of argon, because that's what we're looking for. The question's asking for it. Gram with mole always gets what number? Number 1. I hope you said that. It's like music to my ears. And then, of course, the grams of 39.9, because that's the molar mass. Looky here. Grams of argon cancel. That's exactly what we wanted to happen. And so now we have, this is a little different than last time. We have 8.6 times 1. What's 8.6 times 1? It's 8.6. Okay? And then what's left on the bottom, ladies and gents? We can't ignore what's on the bottom. It's 39.9. So this is what we have here. We have 8.6 times 1, which is 8.6. Bring together down on the bottom, which is 39.9. We have to divide these two now. This is a division problem right here. So in your calculator, you have 8.6 divided by 39.9. I got to two significant figures, 0.22 moles of argon are in this sample. All right, ladies and gents, a good practice is to always box your final answers, okay? I'm going to be looking for that on tests and quizzes as well as your homework. Box your final answer always, always, always as you show your work. Okay, go ahead and we're going to finish up with this video, and I'd like you to try the next couple of examples on your own. You'll find the worked solutions afterwards, okay?